Hundreds of telephone buildings like this one, throughout the Bell system, house the automatic dial equipment that makes it possible for customers to dial their calls accurately and quickly. So quickly, in fact, that the bell rings almost as soon as the last digit is dialed. This accuracy and reliability did not just happen. No, indeed. It came of careful engineering, manufacturing to close tolerances, proper installation, and last, but by no means least, proper adjustment and care by telephone men who know their circuits and equipment thoroughly. Here we see a part of the dial equipment to take care of 20,000 customers. It represents an investment of about $2 million. In this particular city, the switching equipment is called step-by-step. It got its name because each call progresses through the office a step at a time as each digit is dialed. To telephone people, a knowledge of how this equipment works is basic to proper maintenance. Demonstration setup that we will use to show how a call progresses through a 5-digit step-by-step office. It is composed of 5 devices called switches. When the calling customer raises the receiver, a circuit is closed, starting the first switch, which is called the line finder. We'll do it again in a moment. Watch the line finder hunt the calling line. Also, watch the contacts of the line finder shaft, which we call wipers, step in to connect with the calling number's terminal. Now see it happen. The line finder is connected permanently to a first selector, which returns dial tone to the calling customer to tell him that the equipment is ready to receive the first digit. For this demonstration, we will dial the number 35286. The circuit is connected to contacts controlled by the telephone dial. As the dial is moved off normal for the digit 3, no action takes place in the first selector. But as the dial returns to normal, the selector will respond to the dial pulses. It stepped up to the 3rd level, and by rotary action, cut in automatically to select an idle circuit to the next selector. This is the 2nd selector. This switch will operate when the 2nd digit is dialed. The next digit is 5. Again, nothing happens as the dial is rotated to the finger stop. But watch the 2nd selector as the dial returns to normal. It stepped up to the 5th level as it responded to the 2nd train of dial pulses and cut in automatically. The 2nd selector extends the circuit to the 3rd selector. This selector operates in the same manner when the next digit, digit 2, is dialed. The selector stepped up to the 2nd level as the dial returned and cut in. The 3rd selector extends the circuit to the connector switch. The connector operates somewhat differently from the selectors, as we shall see when we dial the first of the last 2 digits. The next digit to be dialed is 8. As the dial is moved to the finger stop, no action takes place in the connector. But when the finger is removed, the connector will respond to the dial pulses and step up to the 8th level. Notice, however, that it did not cut in. This is because it is now necessary to select the called party's terminal in the connector bank. The equipment waits for the final digit to be dialed. The 5th and last digit in this demonstration is 6. As the dial returns to normal, the connector rotates to the 6th terminal. The connector now sends ringing current out on the called line until the receiver is raised. Now let's watch another call as it progresses step by step through the demonstration equipment. If the number this subscriber is calling is in use, the connector will recognize the busy condition and will return busy tone to the calling customer. Let's see how one of the switches used in establishing this connection actually operates. The principles of operation of the first selector are basic to other step-by-step switches. It looks rather complex, so let's put it in a special stand where we can take a good look at it. Actually, it consists of 5 relays designated A, B, C, D, and E. Magnets and mechanical linkage step the shaft vertically. Magnets and linkage also rotate the shaft horizontally. A release magnet and armature release the shaft when the call is completed. This constitutes the mechanical part of the selector. The electrical part of the switch operation is shown in the circuit schematic. This tells a simple story to the experienced telephone man. In some cases, it is difficult to realize the effect of various adjustments on switch operation because of the speed with which it operates. The complete operation takes less than 1 second. However, with the Fastax camera, action can be slowed down as much as 200 times, so we can see just what does happen during switch operation. High-speed photographs like this one have been of great help to engineers in designing the equipment for long and accurate service. And of course, they are of particular interest to all maintenance people, for they serve to emphasize the importance of following the adjustment procedures outlined in the Bell System practices. The requirements in these practices have been carefully developed so that switches will operate with a minimum of wear and perform satisfactorily in spite of minor variations in customers' dial speed or their distance from the central office. Good design, a well-made product, and accurate adjustment mean good service.